Number 48, I'm going to read it right off of the review. It says a zoom lens in a camera makes a rectangular image on a film that is 5 centimeters by 3 centimeters. So we can visualize it this way with length and width. And it says as the lens zooms in and out, the size of the image changes. Find the rate at which the area of the image begins to change. If the length of the frame changes at 8 centimeters per second, and the width begins to change at 0.4 centimeters per second. And I meant that to be 0.8 there for centimeters per second. Okay, so what we have at work here is the area changing when the two dimensions change on this rectangle. So the notation we need to use here is dA dt for the change of the area. Okay, then this is the change in the length, so I'm going to call that dl over dt, where L of course is length. Okay, and then this 0.4 is the change of the width, so let's call that dw dt, where of course w is your width. Alright, now to work this kind of problem, we need a formula of some kind which relates area to length and width. Well, the area of a rectangle is just A equals L times W. And so with this, we're going to use implicit differentiation. So implicit differentiation where we're going to take the derivative with respect to time of both sides of this equation. So d over dt of A equals d over dt of LW. Alright, the derivative with respect to A is just dA over dt. However, this derivative here is going to have to be found via the product rule. Because we've got these two things being multiplied together, the L and the W. So that we'll have to take the derivative. Again, this is all implicit differentiation. So the first derivative of the first is derivative of by the product rule we start with the first times the derivative of the second. So derivative of W is just 1, but of course because our t and w don't match as far as the derivatives go, we have to include a dw dt along with it for the implicit differentiation. So that's first times derivative of the second plus the second w times derivative of the first. Derivative of L is just 1, including dl dt. Alright, so now we got dA over dt is equal to L dw dt plus w dl dt. However, from up above we have the different measurements of these variables. So this 5 is your length, this 3 is your width, and then these centimeters per second measurements are the dl and dw dt. So we'll plug those numbers in. We'll have dA dt is equal to 5 times 0.4 plus 3 times 0.8. And so that gives us 2 plus 2.4, which is going to be 4.4. And of course, since we're dealing with measurement of area with respect to time, this is going to be squared meters per second. So that would be the rate the area changes with respect to time as the two dimensions of the rectangle changes.